Hello and welcome to another video with Leah. Today I'm going to be talking about how to find empirical formulas when given the percentages by mass. At the end of this video, I'm going to give out some tips so that you can get a more accurate empirical formula. For this example, it's asking to write the empirical formula for a compound with 62.07% carbon, 10.34% hydrogen, and 27.59% oxygen by mass. So the first thing we want to do is place these percentages over the atomic mass of the compound. So for carbon, we have 62.07 over 12.01. For hydrogen, we have 10.34 over 1.01, and for oxygen we have 27.59 over 16. Now we want to find the values when we divide these problems. I encourage you to pull out your own calculator and find these values. For this first one we have 5.1682. For the second one we have 10.2377, and for the third one we have 1.7244. Now our next step is to divide these three numbers by the smallest value that we just got, and that would be 1.7244. So we go ahead and divide each of these numbers by that 1.7244 number. Next we find the value of these divisions. So for this one we have 2.9971. For this one down here we have 5.937, and for this one right here we just have 1. Now these numbers here are going to be our subscripts. So we know that we have carbon, hydrogen, and oxygen, and we know that we can represent that by the C, the H, and the O. Those are the element symbols, right? Now, we look at each of these numbers. So this was for carbon, this was for hydrogen, and this was for oxygen. For carbon, our final value was 2.9971, which is really close to 3. So we can say that we have 3 carbon atoms. For hydrogen, we have 5.937, which is really close to 6. And so we have 6 atoms of hydrogen in this molecule. And finally, for oxygen, we have 1 atom of oxygen, which is there. But because it's a 1, we don't show that 1. So C3H6O would be our empirical formula for this question. Now let's do another example. What is the empirical formula for a compound with 85.7% carbon and 14.3% hydrogen by mass? Pause the video and see if you can figure out the answer to this question. Like in the previous example, we put these percentages over the atomic mass of the corresponding element. So we have 85.7 over the atomic mass of carbon, which is 12.01. And for hydrogen, we also have 14.3 over 1.01. So this is for hydrogen, and this is for carbon. Now we do this division. So for carbon here, we have the number 7.1357, and for the hydrogen, we have 14.1584. Now our next step is to put both of these numbers over the smallest value that we just got. So that would be 7.1357. Now we do another division here. So this number would be 1, and for hydrogen we would have 1.9842. Now we have the carbon and the hydrogen, and all we need are the subscripts. So for carbon we know we have 1, so that goes there, but because it's 1 we don't show that. And for hydrogen we have 1.9842, which is very close to 2. So we have 2 atoms of hydrogen in this case. Our final answer is CH2 for the empirical formula for this question. Another example. Find the empirical formula for a compound that has 29.4% calcium, 23.5% sulfur, and 47.1% oxygen. And these percentages are by mass, of course. So for calcium, we have its percentage, 29.4, over its atomic mass, which is 40.08. Next, we have sulfur. We have 23.5 over sulfur's atomic mass of 32.06. And we have oxygen, which has 47.1 over 16. Now we carry out these divisions. For calcium, we have 0.7335. For sulfur, we have 0.7330. And for oxygen, we have 2.9438. Now, our next step is to divide each of these values by the smallest number that we just got, and that would be 0.7330. And we carry out these divisions. For calcium, we have 1.0007. For sulfur, we have 1. And for oxygen, we have 4.0161. So in the end, we know that we're going to have the element symbols Ca for calcium, S for sulfur, and O for oxygen. And now we know that these values that we just got are going to serve as our subscripts for the corresponding elements. For calcium, we have 1.0007, which is really close to 1. So we only have 1 atom of calcium, which we don't need to mark here because it's 1. For sulfur, it's much the same. We just have 1 atom of it. And for oxygen, we have 4.0161, which is very close to 4. So we have 4 atoms of oxygen. Our final empirical formula for this question is CaSO4. Now, I want to go over when the number, the last value that you get, ends in 0.5, 0.33, or 0.25. So far, our last values that determine our subscripts for the elements have been really nice. They've been ending in 0.98 something, 0.01. They have been really clear that we can easily round them to the nearest whole number. However, they won't always give you a subscript number that is easily rounded to a whole number. And so you might end up with something that ends in 0.5, 0.33, or 0.25. And for these endings, these are too far away for you to easily round them. So if, say, for example, you had 2.5, you really shouldn't round this to 2 or 3, as 0.5 is not close enough to round to either of those numbers. Instead, if something ends in 0.5, you want to multiply all the subscripts by 2. So if you have 0.5, you're going to multiply by 2. This is because if you have a fraction, we would agree that 1 over 2 is equal to 0.5. And in order to get rid of this 2 on the bottom, we have to multiply by its reciprocal, 2, so that 1 is on the top and 1 is on the bottom, so that they can be canceled out. So for example, if you had 3.5 and 1.002 for your final values, these values would have been your subscripts. However, because you have a 5 here, you cannot round this number to 3 or 4. Instead, you have to multiply this value by 2 and this value by 2. And in doing so, you will get 7 here and about 2 here. Now for 0.33, you want to multiply all of the subscript numbers by 3. This is because 0.33 is equivalent to the fraction 1/3. And like I said, in order to cancel the 3 down here, you have to multiply by its reciprocal, which is 3 over 1, so by 3, to cancel these out. And you might see 0.25, which you can multiply by 4 in order to end up with a more accurate answer. And here, 0.25, we would agree, is equivalent to the fraction 1 over 4, and we're just multiplying it by 4 to get rid of this. So keep these endings in mind so that you know what to multiply by, so you can get a better answer for your empirical formula questions. Also, you may have noticed throughout the video that I wrote 4 numbers after the decimal point to improve my accuracy. So the more numbers you keep after the decimal point, the more accurate your answer will be. Personally, I think 4 numbers after the decimal point is good. Thank you so much for watching this video. I really hope you found it helpful. If you did, don't forget to subscribe to this channel so that you can know when I post a new video. See you next time!